Hello, my name is Chabikat. My number metric is AE230058. So today our group will present how to use MATLAB to solving the question. We are from group X session 2. So this is my group members. And then our content is solving the question by using MATLAB. So from question 1, the voltage V across an inductor of inductance L is related to the current flow. So given L is equal to 5 H and the current is I equal to 0.2 e power negative t. Determine the changing rate of voltage at t equal to 5, 10 and 15 seconds. Then plot a graph to showing voltage variation of pi of each given time period of a cylinder. So from this question, we need use this formula, that is Ohm's law of an inductor. V equal to L differential current. So where V is instantaneous voltage across the inductor, L is inductance in unit Henry, and the differential of current is instantaneous rate of current charge. So this is a MATLAB solution. So from the first coding, we can see that Sy and St is declared the function of t. So the third coding is about the formula of the current that we need to differentiate it. So the coding for we need to differentiate the current. So the coding 7 is about the formula of the voltage, that V equal to inductance times differential of current. So below the comment window, it is the answer of after differential current. So we can get the answer is negative 2 times exponent power negative 2 times 5 over 5. So for the result, the left hand side is showing the all coding in the MATLAB. So we know that the time is given by the question is 5, 10 and 15 seconds. So we need put in the MATLAB to help us to calculate the voltage value. So the question also given the inductance value. So we also need to put inside the MATLAB coding to constant the inductance value. After that, we substitute all the value into the voltage formula. Then the MATLAB will help us to calculate the value of the voltage. Then we need to plot the graph voltage over time. So we need x-axis and y-axis. So x-axis will label as time, y-axis is labeled as voltage. So the right hand side is the result of the graph plotting by the MATLAB.
Next, let's move to the next question. We move to the question number 2. Question number 2 briefly tell us about RC integrated circuit. So in question number 2, it states that RC integrated circuit is a series connected RC network that produces an output signal which corresponds to the mathematical processes of integration as shown in figure 1. So the question asks us to evaluate the voltage across the capacitor after 30 milliseconds when the RC integrated circuit combines with resistor with resistivity of 1 kilo ohm, capacitor with the capacitance of 10 microfarad, and the voltage in, which is 12 volt. And we need to assume that the capacitor is initially charged to 3 volt. So the formula that we will be using to answer question number 2 is RC integrator formula. So this formula states that voltage out is equals to 1 over RC integrate voltage intake respect to time. So next we move to the manual calculation. So by referring to the manual calculation, first we substitute all of the values into the formula. So as you can see here, we substitute the value of R, C and voltage intake into the formula, as well as the upper limit and the lower limit. So the upper limit in this case is 30 exponent negative 3. And then we simplify the equation and integrate the formula, and then substitute the upper limit and the lower limit, and then we will get 36 volt. So 36 volt is not the final answer for this problem. It's because we want the voltage across capacitor, which is VC. So in the question, it says that we need to assume that the capacitor was initially charged to 3 volt. So we need so VC is equals to V out minus V naught. So 36 minus 3 is equals to 33 volt. Next, let's move to the MATLAB solution. First, we need to list all of the variables. So in this case, the variable is t. So we need to do that by typing SYMST in our script. Then we need to declare all of the parameters in the circuit. So in this case, resistivity, which is R, is equals to 1000. The capacitance C, which is equals to 10 exponent negative 6. And then voltage intake is equals to 12 and V0 is equals to 3. And then we need to declare the upper limit and lower limit. So in this script, the lower limit is labeled A and the upper limit is labeled B. So the lower limit is equals to 0 and the upper limit is equals to 30 exponent negative 3. Then we need to do the symbolic integration and then the result is displayed. So then we will code the result of the integration by substituting the values. So the value of the integration, which includes the upper limit and the lower limit, will be displayed as value. So and then the value then will be times with 1 over RC, and it will be displayed as result of V out, and then the V out it will be minus with V naught and will be displayed as VC. Next, so as you can see here in the result of integration is 12t, and then the result of the integration by substituting the values is 0.3600, and the result of V out is 36, and the voltage across the capacitor after the t millisecond is 33, which is correct and same as the manual calculation. Thank you so much for watching. See you next time. Bye.